So this is 3.5D as in dog, page 311, example number 9. We're going to follow the same 5 steps in the middle of page 310 like we did for example 8. So the first thing we're going to do is we're going to find the zeros of the denominator in order to find out what our asymptotes are. So what we're doing is we're trying to figure out when our denominator is undefined or when our denominator is 0, which will make our function undefined, and that will tell us what our asymptotes are. So if we take our x squared plus x minus 6, this one can easily be factored into two binomials, x plus 3 and x minus 2, which tells me that my asymptotes are at -3 and at 2. Okay, easy enough. Now the next step is to find out what my horizontal asymptote is, or my oblique, but what we're going to do is we're going to look at our exponent here and our exponent here. Since they're the same, we take the coefficient of this x over the coefficient of that x. So my horizontal asymptote, okay, this is my vertical. My horizontal asymptote is going to be 1 over 1, or 1. So it's going to cross at y equals 1. Okay, the next thing we're going to do is we're going to, let's see, step 3, find the zeros of the function. So we're going to try to find out where this graph crosses the x-axis. And it'll always cross the x-axis for whatever makes the numerator 0. So we take x squared minus 1, make that equal to 0. X squared equals 1. So x equals plus or minus the square root of 1, or plus or minus 1, because the square root of 1 is 1. So that tells me that my zeros are at -1 and 1. So that's where it's going to cross the x-axis. Alright, the next step and final step here we're going to do is we're going to find out where the y-intercept is. And we find out where the y-intercept is by making, finding as if x were 0. So x squared minus 1 is x squared plus x minus 6. So that would be 0 squared minus 1 over 0 squared plus 0 minus 6, which would end up being 1 over 6 when you solve this. So my y-intercept is 1 over 6. Okay, so those are my 4 steps there, and there is a 5th step. The 5th step is basically just putting in a bunch of points for your x and kicking out a y in order to get a better idea of what this is going to look like when you're done. But let's go ahead and draw this graph. Okay, so we know where our vertical asymptotes are at, -3 and +2. I know that my horizontal asymptote is at 1. So I'm crossing right across there. And I know my zeros are at -1 and +1. And my y-intercept is at about 1/6. Okay, so now what I'm going to do is try to figure out where some more points are. Like, I don't know where anything's going on over here. I don't know what's going on over here. And I don't know what's going on right here. So I'm going to take my x and y, and I'm going to put in a -2 here to see where that's going to fall along here. I mean, who knows? It may jump up. Well, it could jump up here because a horizontal asymptote, a graph can cross. Only the vertical asymptotes can the graph not cross. So it could jump up here. So let's plug in -2 and see what it spits out for y when we plug that -2 into our original equation here. So when I plug -2 in, I get a -1/4. Okay, so it doesn't just dive down here. It sticks like right in here. So it doesn't go down very fast at all. So let's put that on here in blue, right around that area. Okay, and I know that when I plug a 3 in or a 2 in, it's going to nosedive. So I know that this graph is going to do this. But it doesn't go down as fast here. Okay, so it looks about like that. Okay, so let's put some numbers in over here and over here to get an idea of what it's going to look like. So let's put in a, well, a 1, 2, 3. Let's put in a 4 here and see what that looks like. So let's see here. We put in a 4 and it kicked out a 15/14. That doesn't look very nice, but it is a little bit bigger than 1, so let's just call it 1 at this point. So we went over 4, 1, 2, 3, 4, and up 15/14, so a hair over 1. Okay, so let's see what happens if I put in 3. So I put in 3, and that gives me about 4/3. Okay, so I go over 3 and up 4/3. So it doesn't really do a whole lot. But what I'm finding out by putting these numbers in here is in this area. So it saves me from thinking it's going to be over in here somewhere. Okay, so when you look at these graphs, you plug in some other numbers. I'm not going to do that for you, but you plug in some other numbers from over here, and you'll find out your graph follows this line here. Okay, and that'll be your completed graph. All right, so anyway, that's example 9. Okay, so this is example 10, the last one we're going to do here. And one of the things that's different here is all the other ones that we have done, the factors in the numerator and the factors in the denominator were different. And now we're going to do one where the factors are the same. So look what happens when we factor the denominator here, which is always your first step. We get x plus 1 and x minus 2. So notice that my factor x minus 2 is up here and my factor x minus 2 is on the bottom. Okay, so let's follow the same rules and just keep going and see what happens here when the factors are the same. Don't cancel out anything, but let's just work on it. Okay, so step 1 says that we're going to find out what the vertical asymptotes are. And according to our rule for vertical asymptotes, we get -1 and we get 2. And for the horizontal asymptote, we look at the in the original problem, we look and find out what our exponents are of this one here and of this one here. Okay? So, since the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0, or the x-intercept. So let's just put down y equals 0 so we don't get things mixed up by putting vertical asymptote or the x-axis down. Okay, so let's look at zeros of the function. Okay, so what is going to make our numerator 0? And there's only one, and it's the number 2. Okay, now let's look here about what happens with number 2. If we were to put 2 in here, that would give us 0, right? But that means that if we put 2 in for x, we get 2 minus 2 is 0, which is fine. 2 plus 1 is 3, but 2 minus 2 is 0. 0 times 3 makes this 0, which makes it undefined. So whenever I use a 0 I use 2 to make this 0, I've also made this 0, making this whole thing undefined. And I can't do that because what I've discovered, remember when we've looked at what our domain is? Our domain is what numbers are we going to be able to put into this function that's going to give us real numbers so that we can graph it. Well, our domain is all the real numbers except -1 and 2. So -1 and 2 cannot be in the domain, which means we cannot plug 2 in here because that would be saying we're taking a number that's not in the domain and putting it in here, which is impossible. So we cannot do that, which means that since we can't do that, there are no zeros. And what that means is there's no place in the graph that that the line crosses the x-axis. Because there are no zeros, which is fine, the graph does not cross the x-axis. So one of the things that we've discovered is not only does 2 not work as far as where it crosses the x-axis, 2 is not part of the domain, so 2 cannot be part of the graph because we're only graphing the domain. Okay, so that all being said, let's bring our graph down here and let's put in the vertical asymptote, which is going to be -1. And we've already said that 2 does not even exist as part of the problem. So we're going to throw out all visions of 2. Anytime we see a 2, we're throwing it out because it's not going to work. It's not going to be a possible answer for anything. Okay, our horizontal asymptote is y equals 0. Okay, and we can plug a number in order to find out what our y-intercept is. So we're going to put in 0 for our x's here because that'll give us our y-intercept. So 0 minus 2 is -2, and that will be over 0 squared minus 0 minus 2. So that gives us a y-intercept of +1. So we'll do that in blue here. So we have a y-intercept of +1. And we've already said that the number 2 is not a part of this domain. It cannot be any part of this problem in any way whatsoever. So when we do draw this graph, and as we plug numbers, it looks like this. Okay, but when we get to 2, we have to put an open circle there because 2 is not part of this domain. It's not part of what we're doing. So that's the thing to remember when you're doing these. When you get a factor on the top that is the same as a factor on the bottom, we have common factors, whatever makes this 0 is not in the domain. So therefore, you're going to put an open circle around it where that graph, you're going to draw the graph, and then where it crosses that x number, like this one here was a 2, when we got to x equals 2, which I guess that's not at x equals 2, that's at x equals 1. The open circle should actually be right there. I don't know if I can draw it. Okay. When you get to this number along this x-axis, put an open circle there to show that it's not part of the domain. Okay, and then we have to look and see on the other side of our vertical asymptote, what happens over here. And when you throw in some numbers over here, you get a graph that looks like that. Okay, so that ends up being what your graph is. So that's just a little tweak in there as far as if we have a common factor in the numerator and the denominator, what's going to happen. And whatever makes that common factor 0, we're going to put as an open dot at that place when we graph it. So that's it for 3.5.